Hi, welcome to implementation of binary tree using post order and in-order traversal combination. Here we are passing the uh, post order array and in order array and the length of the array. Then we are initializing the in order index. Starting index is 0, last index is size minus 1. Then post order starting index is 0, post order array last index is size minus 1, that is length minus 1. Then we are calling the build tree by passing in order array, post order array, and starting index of the in order, last index of the in order, starting index of the post order, and last index of the post order. So here now the post index is initialized with the array length. Array length is now here as of our uh, this is size minus 1. Post index is now size minus 1. So this is 5. This is 5. Now we are passing the in order array, post order array, and the starting index is here. The for post order starting index 0, ending index is 5. For in order also starting index 0, ending index 5. So here starting index for in order, last index for the in order, starting index for the post order, last index for the post order. Now we are checking starting index is 0 greater than 5, which is false. So this statement will not execute. Now we are creating the new node. That new node will have left pointer and right pointer. As of now it is empty. For that new node we are assigning the value post underscore in post index. Actually this is post index. Okay, post index. So post index value is now size minus 1, this is 5. So post index is, this is the array post, this is the array post, this is the array in. So now post of post index here 5, that is having the value 1. That 1 is assigned as a new node that will have the left subtree and right subtree. So node value is 1. Now post index is decrementing by 1. 5 minus 1 will be 4. Then we are checking last starting index 0 equal to last in the in order index is 5, which is false. It will not execute. Now we are checking the location of our new node in the in order array. In order array we have to read from left to right. When you are reading the data left to right, we have to search the element is new node dot data. New node dot data is 1. From 0th index to last index we will search the position of new data. So here from the starting index to end index, searching the data 1. Here in order of 0 is 4 equal to data is 1, which is not matching in iteration number 1. Iteration number 2, here in order of 1 is 2 is matching with data, that is the 1. So 2 is equal to 1, which is also false. Then iteration number 3, iteration number 2, first 0th iteration and second, first iteration, second iteration. The second iteration uh, in order of 2 equal to 5, so 5 equal to 1, which is also false. Then iteration number 3, the iteration number 3 1, so 1 equal to 1, which is true, so which is matching. Now we are returning the index value to this variable. So now we are returning the index value to this variable. Now we have returned that. So we are constructing the right subtree for the new node 1. So 1 dot right, we will pass in order array, post order array, in index plus 1. That is in index is now 3. So 3 plus 1 4. Last in index is already we have got 5. Last index is 5. Then last post index is 5 minus last in index is 5 plus in index is 3, so equal to 3. Then last post index is 5 minus 1 equal to 4. So for 1 dot right, this is the value. So now in the in order, whichever elements available right side to the right side to the 1, these elements will become as a right subtree. The elements which are available left side to the 1 will become the left subtree. So here first we will construct the right subtree to the 1. That's why we are calling this method 1 dot right. Here among this 1 6 comma 3 we are not sure which node will become as a root. Here in this location which node will become a root among the 6 and 3. So for that now we are again calling that 1 dot right. So that 1 dot right we are passing the values. Here starting index is 4, this value 5 3 4. So 4 5 3 4, we are passing this for 1 dot right, 1 dot right. Now we are checking starting index is 4, last index is 5, which is false. Then now the post index, what is the post index value? 4. This is the post index value 4. At the location of post index 4, this is the location. So now the post index is having the value 3. So this is the new node we created. Then for this, after creating this new node, we are decrementing the post index by 1. So now this will become 1. So now post index is denoting the location 3 in post order array. Then we are checking start index equal to last index. Start index is 4, last index is 5, which is not matching. Now we are searching the element 3 in order in which location the tree is available. So we are passing the starting index is 4, last index is 5 in the in order. So 4 5, the data is 3, new node is created 3. So the new node is created 3. So that will become a, that will become a root here, root here, right? So now we are searching that searching the data in the search method. Here again now our data is 3. Here starting index is 4, ending index is 5. So 4 5. Okay. So here the starting index and ending in, no sorry, here starting index is 0, ending index is 5. We are passing the values here. Starting indexes, yes, starting index is 4, last index is 5. So now we are searching that, we are searching that. So when we are searching the data 4 2 5, okay, so in order of 4 which is matching the 6. So our data is 3 which is not matching, so which is false. Iteration number 4 which is false. Then uh, iteration number 5. Now so this is iteration number 5. Now we are checking where it is available. So in the iteration number I equal to 5, now 3 is matching with 3, so which is true. So now we are returning the index value I. So now the index value I is returned. Now you look at that, this index value is returned to the in index. Now again we are, new node is 3, new node is 3. So for 3 dot right we have to call this function 3 dot right. In index is here 5 plus 1 6. Then here last index is here we passed 5. So this is 5. Then here we are passing last post index is 3, sorry 4, this value, okay, this value. So last post index is 4 minus 4 plus in index is 5, so it is 5 now. Then last post index is here 4, 4 minus 1 equal to 3. So now for 3 dot right, again we are calling this method, we are calling this method recursion. So now we will pass, the values 6 5 uh, 5, then 3. So this is for 3 dot right, 3 dot right. Still 1 dot left is pending. So 3 dot right, here we are checking starting index is 6 greater than 5, which is null, which is null. So 3 dot right is now null, 3 dot right is now null. right. So still we are having the value, that value is 3, right? So for that 3 dot left, next line 3 dot left we have to pass. So here the starting in index is, again we have to check the starting in index. Now here this is 4, so 4 is the starting in index, and in index minus 1, in index minus 1, this is the in index, that is the 5 minus 1 is of 4, right? Then start position index. So start post order index, start post order index is here 3. So 3 is the start post order index, and start post order index 3 minus 3 plus in index is 5 minus 1. So it will be 3 plus 5 8, 8 minus 4 4. So now we are passing this values as this values as now uh, recursive parameters. So 3 dot left, again we will call here starting index is 4, here this is also 4, and here 3, and here 4, these values. So this is for 3 dot left, 3 dot left. So here you look at that, we are having 4 comma 4, 4 comma 4, here start index greater than last index, which is false, it will not execute. Now we are creating the new node. So for new node, the post order index is 3. So in the 3 we are having the value 6. The 6 is the new node. So new node is created here, that new node is 6, that will be attached here. You look at that, starting index equal to last index, starting index is 4, last index is 4. So now that is returning the new node. So new node is 6, so 6 will be attached as a 3 dot left. So now for 3 the 6 is attached as a left node. So now left subtree is over in this procedure. So now the right subtree is over. So after constructing the right subtree, here we are finding the left subtree for the node 1. So these are the values we have calculated from the previous recursion 1 dot right. So now these values are passing here. 0 is the starting in order index, 2 is the last in order index, 5 is post order index, starting post order index, and 2 is the last post order index. So now here after this, now we are checking, we are reading in the post order. Here we are checking 0 greater than 2, this condition is false. Now we are creating the new node post of index 2. So post of index 2 is denoting the 2. So 2 is the node which are created now. So among these three numbers, 2 is the node we are creating first. So now after created the new node, now we are uh, decrementing the post index by 1. So the index will be 1, 2 minus 1 1. Now we are checking 0 equal to 2, which is false. Then we are checking the new node availability in order array. So here for that we are passing the starting in order index, starting in order index is 0, then last in order index is 2. Here we are passing this one. Our new data is 2, new data is 2, which is created now. Then when you are checking this in the for loop, you will get the index value the for node 1, for node 1. So for the new node 2, the 4 will become the left child. So here we will create two pointers, left child pointer and right child pointer. 4 will become the left subtree, and the 5 is after the 2. After the 2 we are having the 5, so the 5 will become the right subtree. Now here once we reached that, the index value we are getting here for the 2 is 1, right? So now we are passing. So once after getting the 1 dot left, now the current node is 2, current node is 2. So for here we have to find out 2 dot right, 2 dot right. So for 2 dot right, in index plus 1, in index is now 1. So 2, the last in index is here 2, then last post index is here 2, minus last in order index is here 2, then plus in order index is here what we have found 1 equal to 1, then last post index is here 2 minus 1 equal to 1. So now we are calling this, we are calling the recursion build underscore tree recursion. So now we are passing the values here 2, 2, 1, and here also 1. Now we are checking starting index greater than last index, no, it is false. Then we are here now post index value is 1, post index value is 1, so we are creating new node. That new node is post of 1. The post of 1 is pointing out the value 5, value 5. So that new node is created now. Then the post order index is decremented by 1. So once you are decremented, then you will get 1 minus 1 0. Now we are checking the starting index 2 equal to last index 2, these values starting index 2 equal to last index, yes, it is true. Then we are returning the new node. What is the new node? New node is 5. The new node 5 is assigned to the 2 dot right, 2 dot right. So 5 is assigned to the 2 dot right. So once it is over, we have to call for the 2 dot left. So 2 dot left here starting in order index. What is the starting in order index in the previous iteration? 0. So 0, the last in order index is 2. Then here that is last in order index here is we have calculated is 2 for the node 2, right? Then starting position index, starting post order index is here again we are having the value 5. Sorry, here we are having the 2, right? So 2 starting post order index, starting post order index is here 5, yes, 5 comma starting post order index is here 5 minus starting in order index, starting in order index is here 0 plus in order index is 1 minus 1. So now we are getting the value 5. So now for 2 dot left we are passing these values. What are the values? 0, 2, 5, then again 5. So now we are checking starting index greater than last index, no, it is false, it is false. Then we are creating the new node. So this is now index is 0. So for the 0 we are creating new node. In the 0 we are having the 4. So 4 is created. Now again we are checking starting in index equal to last index, which is false. Then we are coming now here 0 to 2 we are checking the new node is here 2, new node is here 2. uh, Here the new node is 4, 4 is the new node. We are searching that location, that location is available in the 0th location, so left side which is not available. So here in this location actually this will become 4 will become the left side. Here it will become actually the starting index is also 0 and last in index minus 1. Yes, here it is wrong. You look at here, in index is here 1, in index is 1, so 1 minus 1 is 0. So here we will pass the 0, we will pass the 0. So here the after creating the new node 4, we are matching the starting index equal to last index, so which is returning the new node. So 2 dot left will become the new node. That new node is the 4. So 4 is assigned as a left subtree. Now we reached the post index into 0. After that we will not get, so here we will get the minus 1, we will get the minus 1. So first order index is reaching the minus 1, so all the symbols are visited. We can stop the algorithm. Thanks for watching.